All right. Hello, everybody. Welcome to the April Rust Gamedev Meetup. This month we got a few talks today, and so I'm pretty excited to see what they have going on. But as always, the point of this meetup is to show off what cool stuff we've been doing in the Rust Gamedev ecosystem. And so I have like a little small thing that I've been working on. I was doing Ludum Dare 50, and so Ludum Dare is a game jam, and for compo, you have 48 hours to make a game, and you have to make it by yourself. So I was like, okay, I'm making a game in 48 hours. And I was using GD script and Godot. And then at the end of the 48 hours, I'm like, my main mechanics aren't as strong as I want. So I'll step down to the 72-hour option. But then come the end of the third day, I'm like, oh, this is really not like as far as I need. And so I'm like, okay, well, if there's another option this time for Ludum, you can do a 3-week jam. And it's made for people to be able to choose which weekend you want to do it on. And so you're not like putting in a full 3 weeks. But then I'm like, but what if I do put in a full 3 weeks? And so I made a commit, rewriting it in Rust. And now we're going to be using Godot Rust. And so I'm super excited about this because it's my first time giving this a try. I love Godot. I love GD script for some stuff. And I get really mad at it when it breaks because I'm trying to pass a number into something else expecting a string and it's not telling me until runtime or whatever. And so I started rewriting parts of it in Rust, and I was like very pleasantly surprised with how rewriting some of the scripts works and kind of getting a picture of what's required for it. And so I think one of the other really cool things about trying this out for working on a game in Godot is that I've been able to sort of explore what unsafe Rust looks like. And the reason for this is because Godot Rust's bindings to Godot have to sort of do some interesting stuff that Rust is not normally familiar with, or not familiar with, but like you can't do in safe Rust. You can't hold on to a reference to something that may or may not exist the next time you try to access it. And so it's been cool to kind of break out of the world of safe Rust is the only way to program Rust. And so this is what I've been working on. And maybe next month I'll have a game to show off about it. But for this month, I'm just showing you how cool Godot Rust is. But that being said, do tell us in the chat what other people have been working on. I'm always happy to mention when people have done some pretty cool stuff this month. And as always, make sure that if you do have cool stuff that you're signing up for the show and tell at these meetups, and then filling out stuff for the monthly newsletter. There's definitely a lot of really cool stuff going on in the ecosystem. And so for today, we have 3 different presentations, and depending on the time, I may or may not show off some new Valorant stuff at the end. I'll take a look at that, but we'll see. But first of all, we're going to be going over DIMS with Norin. We have Hackafu back to show off some new stuff with Noumenal. And then Kevin, and I apologize, the True Doctor is supposed to be mentioned on here as well, but it's only written Kevin here. So we have three talks for today. And so with that, we will be back in just a minute with DIMS. All right, good. So we are here with Frederick, who is going to be giving us an update on the progress on DIMS.
Cool. Thanks for having me back from last time.
Absolutely.
Yeah, so I figured I'd show a little bit what we've been working on in the past month, and just to reiterate kind of what DIMS is. So DIMS is this platform that me and 3 other people are working on here in Stockholm. And the idea is to build a platform where anyone can build their own open world games, or where you can tell like really epic stories. Like we want to create these huge landscapes where you can create your own adventures, basically. And we're building this in Rust from scratch. And in the past month, we've been focusing on the landscape editing tools. So that's what I'll be showing here today. So this is DIMS, and this is when you create a new world, and you'll start out with just water. And then what you can do here is that you can start to kind of paint on in the water. And what's cool here, first of all, is that you can kind of paint wherever you want. Like you can start over here, and you can go to the far view, and you can see that you can kind of, you can go wherever you want here. And eventually it will show up here as well. And you might notice that these materials look a little bit different. This one is a bit more gray, and that's because there are 2 different types of ground, or two different types of rock. So what we can do here is that we can pull out this erosion brush, and you can actually start to erode things. And these 2 will erode slightly differently. So let's actually paint a bit more here before we jump into this. So something like this perhaps, and maybe, I don't know, maybe we want a mountain over here, like something a bit bigger. That's all up to your imagination. And we also do have some 2 choices of brushes. Like we have the circle, and then we have a square one. And the square one you can kind of use to create these kind of unnatural shapes. But then you can use the erosion to kind of make it into something that feels natural in the end anyway. And it's kind of an interesting tool to create more interesting landscapes. And what's cool here as well is that you can actually, let's first of all just jump into this, because you can go down into your world once you started crafting it and kind of take a look, and eventually you'll be able to create your full adventures in here. So this is what we just created here, and all of this works in multiplayer fairly well right now, but we're working on making it perfectly seamless. And the last thing I wanted to show is that you actually you have 2 different types of rock, but then you also have on top of the rock this soil layer that you can place. So what you can do is that you can kind of start painting soil on top of this, and the soil behaves differently from. You can kind of see that it's got a much smoother surface. So if we fly over here, it takes a while to get over there, but you can kind of see that the soil, or like the grass landscape, becomes much softer than the rock landscape. And in the future, we would love to add more types of landscapes. So yeah, that's kind of what we've been working on lately. We will also have a competition probably in the middle of May where we'll invite anyone to come and create their own landscapes and then create the coolest screenshot out of that, and we'll create a competition out of that. We don't know exactly how it will be, how we will do it exactly yet, but something like that. So it'll be fun. Hopefully some nice prizes as well. And the final thing I wanted to mention is that we're also hiring. So if you're a Rust developer and you're interested in building for open world games, or like this, basically this editor for open world games, then you can contact me. I'm in the well, you can go to dims.co to find more information about us. And we're hiring both in Stockholm and remotely. So yeah, I guess that's pretty much it for me for this week.
Nice. I have a few questions here. Can you pop back over to the game for a second, or I guess the engine?
Sure.
So one thing I'm curious about. So first of all, just like looking at this screen, and then when you're in game as well, how have you found building tooling that is designed to be like used as an editor? Like, what's the process behind that?
Yeah. So I tried a bunch of different paths here. So we started out with like something where you actually used like a rock texture, and that's kind of what I showed last time. So you had like this texture that kind of, you know, it was these mountains that were already in the textures. When you raised it, it started looking like a mountain immediately. But we found that the landscapes kind of became, you could feel that they were repetitive because they were based on a texture. So I already had this hydraulic erosion system implemented. So we kind of went back to that and I started experimenting more. And we just found that you could get more variation and like more unexpected landscapes with it. So we just felt like, okay, that's much more in line with what we want to do. And we also wanted to create a tool that, you know, felt very physical almost. Like it I can feel that I'm like eroding this. It's not a very, it doesn't feel technical to me in that way. So that's also, that was also a very important thing for us.
Mm-hmm. And I mean, on this topic as well, so we're talking a little bit about how when you're doing erosion, it feels like you're an artist, you're able to paint on stuff and it doesn't feel too technical. But I'm wondering, what might this step into once we start looking at stuff like, as an artist, I want to be able to create a lot that is like logically placed, for example. And so or what I sort of mean is, as we change the terrain, do you have any plans for systems that are like, oh, because there's a mountain here, there shouldn't be trees, and on the grassland down here, because it's close to water, maybe it should have some other textures that are a little bit different? Or have you thought about that?
Yeah, that's part of our plan now. So, for instance, these greener areas, that's where grass and trees will grow. Um, and you know, long term, we'd like to have a couple of different parameters that you as a user have control over. So, for instance, you might be able to decide that one area is wet and one is dry, um, or maybe one area is cold and one is hot, and then out of that you'll get different types of grass, different types of bushes, and different types of trees. um, you might not be able to like place individual trees. Like we'll always have this, you know, we want to make it high level, the tool, so it's easy to do a lot with it quickly, um, at the cost of, you know, getting the full control of your
Mm-hmm.
creation. But we kind of, it's this like, you know, what do you call it, like a random assisted creation tool, basically, that some parts of it are random, but you also have some control of the inputs, and those two things together create something interesting.
Yeah. Okay, so I think I see what you're saying, where like when I go and look at some really big open world game, I can imagine that if you had to place every tree and everything and every piece of grass, then it would definitely be a lot of work. Yeah, so I think this is definitely a good way to go about it. Is like thinking about it from a very high level. You're there to just create broad strokes, not necessarily everything. And actually, as we're at this level, you mentioned that there's like seamlessness where you can load this map into multiplayer and sort of we're looking at a massive map, but you can also hop in very easily. And so as you're editing, do you imagine that it's something that people can edit together in a multiplayer sort of way, or like maybe like a Google Docs sort of way? Or is it more just you load it into the game as multiplayer?
No, you can actually edit uh, together already now. Like we tried like in the office where multiple people in the same world editing it, and it's really cool when when you're standing in the world like this and you see someone else kind of lift this other part of the terrain. um, and of course we have some like uh, bandwidth issues because it's a lot of data to transfer, so we're working on solutions to make that better, but we already have like a pretty smooth solution that works in the office. um, so yeah, but that's the plan for us to be able to perfectly smoothly work together with other people.
Nice, nice. And I'm definitely excited to hear over like the next few months. So I think you said like in May you're looking to do a contest. I think we've seen this with a few other projects. I think with the Bevy Jam there were some prizes. With Graphite they had some interesting contest stuff as well. And so in terms of how people can sort of get going with this contest, if I'm not mistaken, was DIMS like a closed beta and now it's becoming more open, or is it free to download for anybody right now?
So we had it open for a while, and then we took it down, and now we're going to open it up again. And we'll see a bit if we take it down again after that, or we keep it open. It's very much in the development phase, so we want to try to keep it open as much as possible, but we're also figuring out how the product should work at the same time. So sometimes we have to take a step back and realize that, okay, this part doesn't work, and then we have to rebuild that part. um, but for the competition, it will be completely open, and everyone should be able to join and hop in for free.
Yeah, I really love this idea of being able to sort of see what landscapes people come up with, because there's gonna be so much creativity on like what people design and stuff like that. So yeah, I'm super excited to hear updates on that, and also I'm more than happy to share stuff on that for like with the Rust Gamedev Twitter. I think it would be quite popular to have a little contest like this.
Cool. Yeah, we're super
All right,
excited, so it'll be fun.
awesome, good stuff. Well, I hope to see you next month as well, and thank you for showing off.
Thank you for having me.
All right. Hello, hello. Welcome back. Now we are going to be taking a look at Noumenal. And so this was something that I was like super surprised with last month, just because I had no idea that this existed. And so I'm like super excited to hear some of the updates. And so Dusty, I'll let you take it away.
Okay, thank you. So this is Noumenal, and it's a 3D modeling app for anyone who hasn't seen it yet. It's designed to work on a touchscreen with direct input. So that's the basics of it. But I have something really exciting that I don't know if any of you remember as kids going into like class, you could bring in something to actually show and tell. And so like as software developers, we rarely get to actually touch anything that we've created. So I don't know if you can see this, but I have, I was able to 3D print and create this cube that I have on the screen using my 3D printer. And so, yeah, it's pretty cool to be able to create things now. It's able to export to STL, which is a commonly used 3D printing format. And the trick is really not generating the STL files, because it's just a list of triangles, which is pretty easy to make. But the trick is creating an STL that will actually print. And so so yeah, a lot of people have been asking for this, and I kind of it's like, okay, well, that's kind of difficult because doing that, my previous constraint was doing it real time. So if you try to do this exact same cube on some other software, it can take like about 15 seconds or so. So it's pretty cool to be able to do this. I actually had my daughter created a few models and herself and printed them. So yeah, I guess it's a really quick update. I was able to implement a few other things as well. One thing that was actually a lot more work than that was implementing non-uniform scaling, and so that's where you can like stretch a shape in any sort of axis. That was difficult because most game engines only don't support shear, and you really need shear to support this. So I had to modify Bevy heavily. And then also I used a new transform representation where it's kind of interesting, where you actually, it's like an affine transformation where you have a matrix, a 3x3 matrix, and a translation. And then I kind of stuff a quaternion in between those. So that gives you an extra like degree to rotate, and yet you can still integrate the shear in that 3x3 matrix. So yeah, that was kind of nerdy, but the really cool update for most people is this, and for me, I guess, is this being able to create 3D shapes.
Just to interrupt you for a second, a question on that. Someone asked, that's awesome. What scale does it output at?
So most 3D printers, you just scale to whatever you want. So scale is kind of irrelevant. And that's actually a design choice that I made. You'll notice the lack of axes or anything like that. It's because all kind of placements are relative to something you're interested in. So yeah, it's just whatever size you want, you can print it. I don't have any numeric entry yet. But
I gotta say, I love this idea myself. The idea of being able to like sort of model in like these super simple, like with these CSG shapes and stuff like that, and then just send it right to my printer. Like this is super exciting.
Yeah. I wish there was a slicer for mobile as well, so you could just send it straight off to the printer. But I suppose with Octoprint, you can do that pretty easily. So yeah.
Perfect. And so another thing I was wondering about is when you're sort of modeling some stuff together, or like you're putting stuff together, and then you do these transformations, whether it's like scaling one axis or something like that. What is the effect once you start bringing in other shapes to keep adding? Like, is this something like you just want to scale it at the end, or how does that sort of feel?
The scale really doesn't matter much because, like I said, when you actually take them into your slicing app or your to your printer, that's where you'll set the final scaling.
Oh, sorry. I mean, like, rather when we're modeling something, like, let's say I'm like modeling something, I get halfway through and I'm like, okay, I want to make this like a lot larger. And so all of the stuff on it shifts quite a lot. And then I start adding more stuff on top that isn't scaled at that amount. I guess.
So when you can do this global, so let me put another shape on the screen. So you can do like global scaling where it'll scale everything on the screen. So that's doing a global scale. And then you can scale individual shapes.
Okay.
And then you can also, that's actually behind it, you can bring it forward. So unfortunately, I wasn't able to figure a way to do scaling and Z-axis movement in the same, like without having to press a button. I did try that, and the feedback was that's confusing. So, so yeah, you have to kind of toggle this scale button to decide whether you're going to move forward and backward, or if you're going to scale. But it works pretty well. So I don't know if that answers your question. You can scale shapes individually, and you can scale them as like an entire scene. So that's useful. You can kind of get this workflow where you can. One other thing that I didn't mention is you can sort of pin one shape, and this is kind of advanced usage. But like I can touch this cylinder, and then I can move everything else, and then that stays fixed. And so, yeah. apparently I got the screen messed up. So that allows you to work with different shapes at once. So
I think like the way that I picture that is like, let's say I'm making like a humanoid or something like that, and then I have like the body, but I want to like adjust one of the like, or yeah, I guess I'd want to move everything around the body to put it in place or something like that. Then I guess that functionality can make it a bit easier.
Yeah, one concept that seems to be a little bit hard working with this is that you really want to work on one thing at a time. So this was actually inspired by stack languages, which is why the bottom is called the stack. So you really want to like work on one thing at a time, and whatever you're not working with, you put it down in the stack, and the stack also works to group items. So if you're, I don't know, another project I have is a stack language, so I kind of think that way. But it's good to, I found in 3D modeling in general, it's good to keep your focus on one thing at a time. So you build things up, like instead of working on a large model at a time, you work on it bottom up. And so you would work on like the head and then build up the different parts. So and then the shelf on the left is kind of like, you can think of it as like the goal originally was to make that basically like version control. And so you can think of that as checkpointing your work anywhere, and you can drag over to there. Really all it does is it checkpoints like the model, and then you can bring that out and make as many copies as you want. So what you would do is you'd keep on making, instead of being able to go back as in some 3D modeling apps and like change what you've done, instead you can sort of checkpoint things that you've done there. So I hope to expand on that later, but as it is, it's a pretty useful model for working.
Yeah. And also, so last month we talked a little bit about how it was like released so people could sort of try with the beta on iOS. Have there been any like moves forward on like either releasing it or getting it to expose to different platforms as well?
So the plan is still only iOS for now. If it does well on iOS, I will consider expanding to other devices or whatever I can do. Probably would be limited to a touchscreen for now. So it works better on a tablet type device. The reason I have not been real interested in Android is because the tablet situation is not great there. So, and then also the processing power is much higher typically on an iOS device. But that said, I have been able to get it to run on phones, and I have been able to get it to run on like an iPhone 8. So I have an iPhone 8 now that I tested on, and it actually runs surprisingly well. I was kind of surprised by that. So that would imply it has about a third the processing power of the latest stuff. So that would imply that it'd probably work okay on flagship Android phones and tablets. But that said, I'd need to justify the time required to do that. Most of the app is cross-platform, but all of the like UI interactions and interactions with the App Store, those would have to be rewritten. As far as release, as soon as possible. The plan is probably about a month or so. I was hoping to have it out last month, really, but went to GDC and that took up a week of my time, and then a bunch of other stuff, and then I added 3D printing capability as well. So yeah, hopefully soon. I can't say exactly when, but it will definitely happen this year, and it should happen before summer.
Nice. That's exciting. I think I really see this as being not just, or so the way it looks is like a toy sort of, and so we can go in, like you can put stuff together, but I think the ability to export to something that you can 3D print really adds a lot of different possibilities for people who want to use it professionally, and especially like I mean, with what I see, I would be able to use it quite easily to model stuff for games. And so with the like sort of these three different demographics, like as like a toy versus as modeling for 3D printing versus as modeling for games, is there one specific path that seems like the most or like the largest demographic that would be able to use it?
So it's funny. Like, I never intended to make it as like a toy. It kind of looks that way because I tried to make it as simple as possible. And then my main beta tester was a 4-year-old for a long time. So that probably influenced it as well. But I see the main advantage versus something like Blender. I figured I could never compete directly with any of those things, or even in on the iOS App Store. There's some pretty professional looking 3D modeling apps, but none of them are very usable. And I've found that even as a pretty technical person who's really interested in 3D, I've hardly touched Blender. And I haven't, I've spent some time with Fusion 360, but it's always just like, it's just as needed to print a bracket or something. And it's never been very enjoyable. It's always been kind of annoying. So the primary goal was to make something really usable, like by somebody without any training. And I think that opens up a lot of things, because 3D printers are fairly well. I mean, you can go to places and have it printed if you don't have one. You can even order stuff online. So opening up the ability to model for people that with, only a few hours of training maybe, or just a little bit of time to figure it out, is a pretty big thing. And the reason there's the focus on like GLTF exports is because my original purpose for designing the library underneath it was, this was really meant to be a game engine, essentially. I build on top of Bevy, but I've added quite a bit in terms of geometric modeling. And so to allow you to do things such as destructive environments and such. So I thought it would be good for helping me to make some games, because I plan to keep releasing things. So that's also an important market. And then 3D modeling, because, I don't know, just because it's cool. It's something I do that's useful. That was never kind of the primary goal to write this, just because I thought it was already pretty well served by other apps. But I think having that on top of an easy to use app is a pretty big thing. So yeah, I guess all three of those are important. And the direction, so like as far as marketing this thing, it's been interesting. I went to GDC expecting that I would find a lot of people interested in it, and people were interested in it, but apparently not enough interested to actually try the beta. As soon as I was able to do 3D exports, I got like 20 or so beta testers, almost like overnight. So
wow,
people are super interested in that, which makes sense. I have had people ask early on. So yeah, I guess like anything, it's not real clear what direction you're going when you start. I didn't have like I did my best to plan out where this was going, but it didn't go exactly where I thought it would.
And sort of just one of these topics on, you described that the user interface on tablets is really nice. So I'm kind of curious. So one question we had from the chat was, is this possible in the web? And you described that it's mostly iOS. But what I'm curious about is, do you think that there could be some type of extension where I'm able to use a touch interface like a tablet and then have it send the input over the network to like a web-based interface or something like that?
It would be possible. The question is, would it be good? I mean, I think that the latency from touch to display and back, or from hand to eye response, is pretty important. So I've focused on that, and I've done a lot of work in improving that and improving the response time. And I found that even missing it, like even a single frame delay, even on like a 60 hertz or 120 hertz monitor, can be noticeable, especially when you're moving things around. So I guess it would be, if you're willing to give that up, it would work okay. The other problem is that I'm using multi-touch, and I'm not sure it's probably well supported on web, but that would be difficult. And then I mentioned the computation power. So it is running across all cores. It'll saturate them if it needs to. It may not look like it's heavy processing, but when things are intersecting, specifically subtraction, it can be kind of and also union, because a union is just uses subtraction underneath it. But so until you really look at these things, like they're pretty complex. I guess to show you, I think I showed last time, but you can see the wireframe of that cup. But of this, if you look real close at this is my benchmark shape. So it's pretty complex, and now it's removing the interior faces. So I don't know how all this shows over video, but it's so each one of those little polygons you see is part of a convex hull, and so there's thousands of shapes being modeled there or being shown on to the screen. It seems like it's pretty GPU heavy and CPU heavy. It's almost balanced. So doing that on the web would be kind of difficult.
Yeah. I think the way that I sort of see it is like when an artist has like their tablet or something that they're drawing on, there is that amount of separation where you're definitely like not interacting with like the tablet itself. You're interacting with what the computer receives as input. But I do understand, like, if I was what you're saying, if I was moving a shape around and I saw it lagging behind my fingers a bit, then I wouldn't have the same precision that I would have if it was real time. And so yeah, that's a great point.
And it's especially noticeable here because it draws markers. I mean, you can't see my fingers, I guess, on the screen, but so my fingers are where the circles are. And when I move them, the circles track my finger. So if there's lag, it's visible as the circles slipping away from your finger.
Yeah.
So it is noticeable.
I suppose the easiest test is like if you were able to just cast from your iPad to a TV and try playing around with it and seeing, there's probably like half a second of latency or like see what that felt like. But I do imagine that would be pretty yucky.
Yeah, the latency for somebody watching it isn't bad because it's wherever you have that input loop where I do something and then I expect it. And I think it's especially bad on a screen because you can see very closely. Like if it was on a mouse, you probably wouldn't notice. But when you touch the screen and you have something actually trying to track your hand movements, I think it's very noticeable.
Yeah.
And then I guess another thing along that line is another design goal of this app is for it to be something like a musical instrument where you actually enjoy using it. And so that's where like these latency things and just like the graphical quality are important because like those small irritations build up and just kind of make you not want to use something. And so the goal here should be like that, or one of my goals is that it's just fun to play with.
Yeah. And sort of on that topic, one more question from chat. How easy is it to build a model from scratch? So I think we've seen like some complex stuff together. But like if you're just getting started on a blank canvas, what does it look like?
So if you go to the website, which should be on the screen, noumenal.app, and then it's got the .sphere on the end. But anyways, if you go to that website, there is a video it's a tutorial and I walk through creating a simple model. So you can kind of see how that works. If you're familiar with CSG, it should be pretty easy for you because it just uses primitives and you subtract and add those. And so if you can break down any shape into those primitives, you should be able to model pretty easily. That said, there's some like if you watch that video, the eyebrow is kind of unintuitive. I also have this I have like a flower, which I found.
I like the GDC cup. Nice.
I made that at GDC. So I have like this flower that I made.
Ooh,
and
wow.
So that looks a bit more complex. So you can learn some tricks like the leaves. They're really just a sphere and a cylinder subtracted, but slightly offset. So I get that you can see it underneath on the left. And then you just really stretch them out and it makes like some nice leaves. So there are some techniques you can learn after you do some basic things. But I find it pretty easy to use, but I am probably the world's expert on using this app. My goal is to make myself not the world's expert. I've been trying to find some 3D modelers who'd be interested in using it because I figure I'm probably a terrible 3D modeler, even though I've been interested in it for a while. I've never done it professionally. So yeah, it'd be interesting to see what other people can do with it. But this is probably... That's not my most complex. My most complex is I made a duck scene.
Wow, yeah.
It's not...
That was pretty crazy.
It takes a while to zoom. But anyways, I've had some trouble with the scale on the screen. It seems to come in large. That's where you were talking about how do you set the scale. It kind of... it actively ignores scale. Global.
Wow, this is crazy.
Level. And Bevy's shadow. So I guess to complement Bevy, the shadows really added a lot when 0.6 came out. So that really seemed to seem to help with depth perception.
Mm-hmm.
Yeah. So.
Yeah, it's looking pretty great. I think definitely, I mean, we've already just talked about it with DIMS a little bit, but maybe having like a contest in the future where you can have people come in and just try to make cool stuff. I think there's a lot of potential for that. And then also, I mean, I love this idea of the future where I can be riding home on the bus, model something on my tablet, send it to my 3D printer, and it's ready in the morning kind of thing. Like that's like a pretty cool kind of, I don't know, way to look at this in a way that I haven't before. Yeah, but this is pretty great. So I definitely hope that we see a update on the release before next month. But no pressure, of course. I know there's a lot of stuff going on, so it's lots to ask for.
I'll do my best. If anyone's interested, you can have a Discord, or I don't know. That's probably the best way to get updates, or follow me on Twitter or something like that. Yeah. Oh, awesome. One more thing is I wanted to mention, you asked what it's like to work on an editor. I just wanted to say, like, working on an editor is surprisingly difficult because you have users that can like turn things any which way, where I think that games maybe or other things are kind of a little bit like you can control the camera angles and things like that. But an editor seems to be a good way. I noticed when I made my library, like once I had an editor for it, I could break things pretty easily. So having that infinite ability to control things tends to break underneath.
Yeah. All right. Awesome. And I think, definitely having people come in and play test. And I mean, I think that the 4-year-old play tester is like a really great way to really see what can go wrong, because young people are really good at finding edge cases that we don't think about.
Yeah.
So that's great. All right. Well, thank you so much. And hopefully we'll see you next month.
Thanks.
All right. Hello. Welcome back. And we are going to be finishing off today's meetup with an update on Graphite. Now, Keeban, your camera's off, but I just want to mention that. Yeah. All good. I'll let you all get started.
Okay, great. So let's begin with an update on this month's progress with Graphite. If you're not familiar, Graphite is an open source image editing tool for both vector and raster graphics, which is also aiming to be a node-based tool, combining some of the procedural approaches to more of the traditional approach using a canvas and tools and a WYSIWYG editor to create 2D graphics. So let's start out with showing off some new design mockups for the layer panel and also the node graph. So the entire goal is to have it so the node graph and the layer panel are equivalent to each other. So basically, in this past month, we've done a bunch of design workshops and figured out more precisely how that's exactly going to work. And here, you've seen it without the node graph overlay. And if you just tap the spacebar, it will open up and show you it will show you a very quick way of previewing the node graph. And that's because frequently you're going to be competing for space. If you only have one monitor, you'll want to be able to display both of them and jump back between them. If you have a second monitor, you can actually just open up the node graph entirely in a separate window. And also, if you don't have much screen space, you can also just use the layer panel, which we see over here. And that's a very useful way of dealing with most of the things that you need to do on a daily basis. And it's also more familiar with people who know how traditional vector and raster editors work. Usually it uses a layer panel, so you can use that most of the time. But then when you need to do something a little bit more fancy, you can either tap the spacebar or use a second monitor or switch to a different tab and open up the entire node graph. So quickly going over how this works, we have an image. So let's actually start out with a layer panel. We have basically two major folders. One is the flying jet cutout, and that is just this selected jet here. That's an overlay. And then beneath it is the actual backdrop, which is Death Valley here in the background. So the way that this works is we have an image at the bottom, and then reading up the stack, because things in a stack are stacked vertically, we have an image, and that image then gets masked, and that basically cuts it out. So instead of being the original photo that was taken by a camera, it gets cut out by a mask. And that mask is driven by this this vector shape. So that was drawn with the pen tool, and it's just cutting out the outline of the jet. Then on top of that is the transform. And what that means is that by default, layers don't actually have a transform. But if you give it a transform node, if you feed it through a transform node, it gives it a transform. So you can see up here, we have location, rotation, scale, and as well as the dimensions. And this allows you to actually move it around the canvas. And that allows you also to have these transform gizmos when you have the select tool selected. And then, by the way, when you use the select tool and you want to drag something around and it doesn't have a transform, it'll automatically apply a transform node to it and feed it through, so that way it automatically does it for you. So then once we have the image that got cut out with a mask and given a transform to drag it around and scale it, then finally it gets motion blurred. And this motion blur, it takes basically, if we see we have less motion blur on the left side and more motion blur on the right side, but we also have less motion blur on the cockpit. So basically that is a grayscale mask, and you can kind of see how that looks. Oops. I can zoom in, but I forgot the keyboard shortcut. There it is. We can see that there is this mask here that's powering the motion blur. And what that means is we have a gradient, and that gradient then has this folder composited on top. And this folder is that little bit of a white brush stroke. So basically we draw with the brush stroke and then we blur the brush stroke so it gets more smoothed out. And that gets put into a folder. So basically we have a gradient, and then on top of that gradient, we composite this little brush stroke that covers up the cockpit and makes it so the cockpit does not look as blurry. So that's how all of that works. Basically, these thin lines here refer to the flow of data. So the image flows into the mask, which then flows into a transform, which flows into a motion blur, kind of similar to how most node-based systems work. And then this thicker line refers to compositing. So this is more of like a traditional GIMP or Photoshop style interface where the layer panel just stacks things on top of each other. And the things underneath and the things on top get composited with each other. So when it's a thick line, that's when we have pixels that get composited on top of each other. And then similar story also for the node graph. Similar story for the Death Valley backdrop, but I won't bore you with all of those details. And then here's the equivalent view. So we have the image that then flows into the mask, and the mask, the actual stencil of the mask gets provided by the shape. Then it feeds into the transform, and that flows into the motion blur, and that is fed by this entire group here. And that finally flows into the output here at the top, and it gets composited with the thing beneath it, which is the backdrop. So the backdrop is drawn, and then the pixels that are above that as part of the jet get composited in, and then it feeds into the output here. And similar story, of course, with all this.
Sorry, just going to interrupt for a second. With that graph that you just showed, is that something that is actually like you can pop this up on the screen?
Yeah, so you just tap the spacebar at any time, and it will pop up with the node graph.
This is amazing. I love this so much.
It gives you the equivalent view of the layer tree. So the layer tree is more of a compact view. And you might actually see, for example, image and color correction, this little group here, and we label this group landscape. So basically, you can take the output of a group and you can give it a label. But we're actually using it twice here. We're using it both for the compositing. So we have the landscape that gets composited with this darker sky, and then it feeds into this group here, which then feeds into the output after it gets composited. But basically, the landscape gets used in both the compositing as well as feeding into the magic wand, which basically selects the blue areas and gives you a mask out of it. And then that feeds into the stencil here. So basically, we're using this twice. And as a result, if you look closely here, we have both the magic wand taking this landscape here, as well as this landscape here. So these are actually the same thing, because you see that is this stuff. But it gets fed in both here, and it also gets shown in this layer stack here. So as a result, we have landscape showing up there as well as here. And basically, you just see it twice. And that's why we also have a little number 2. It's very hard to see, but there's a little number 2 there saying that it's showing up twice in the layer panel.
Yeah, I think the really interesting thing about this is that it gives a different language to how we think of stuff touches one another. Because whenever I've done anything in Photoshop or Illustrator or anything else, it's always incredibly stack based, right? And so with this, we still have the stack, but we can look at it in this 2D form that allows us to have a better mental model of it.
Exactly. Yeah. And the tool will often, like the tools that you're using, for example, if you use the Magic Wand tool, it will automatically select stuff for you and build the node graph in the back end. If you're not even looking at the node graph, it will build the node graph for you as you use the tools. So you don't have to worry about how to link up, this output to this input and so on, because it'll do that for you, and it'll keep things organized and stuff like that. But if you want to jump in and modify things, you can either do the simpler kinds of modifications where you can't really necessarily like drag one node between an input and an output in the layer panel. If it's too complex, you can rearrange things, but you can't really completely drag things around and modify the entire graph topology. But you just hit the space bar and view the node graph, and then you can really easily just drag the different nodes around. So that's what's really powerful about it. But you still get to keep all of the advantages that you're used to of a simpler kind of style of Photoshop or Illustrator or GIMP or Inkscape kind of interface.
And then just to elaborate even a little bit further, so a question from chat: can you preview image states from a point down the stack? And so, for example, with the darker sky, are we able to see what just that is?
Yeah. So one way, of course, would just be toggling the visibility of one of the layers. So if you just toggle the flying jet cutout, that will make it so you only see the backdrop. But then you can also go and basically solo a layer, and that allows you to solo everything that is fed up to that point. So everything that is down or that is upstream will feed into the point where you're soloing, and then you're viewing only the output of that one point in the graph.
Mm-hmm.
And basically what that means is we're moving the we're moving the output temporarily from here to somewhere else that you're looking at it.
And then just also for a little bit of clarification, we talked about how we could change stuff in the sort of like the tree on the right, like the normal tree we'd expect. But with the nodes in this node graph, would I be able to click and drag output to some arbitrary point and see what that is? Or could I move nodes around in this graph view?
In the graph view, you definitely could just drag, draw, if you wanted, you could just connect this to the output, and that would replace the other output. But there's also an even faster way of, I think will probably be like control clicking on any node output, and that will be the way of previewing the output as more of a temporary thing. And that way it doesn't destroy the previous connectivity that you had output connected to. So we don't want to get rid of this connection, but we will have like a temporary way of overriding the view.
Mm-hmm. Yeah, because I think when it comes to this idea of graphical debugging, I'm not sure where this is going wrong or why I'm getting this layer looking like it in a certain way, then being able to just quickly with in a visual sense like this, move and drag stuff around, or have an easy way to click on something. You
could also just view the thumbnails. So that's another way of seeing the output of individual things. Yeah. So anyways,
awesome.
That is...
Sorry for the interruptions.
No, that's great questions. Thank you. That is the result of a bunch of work on the past month, designing in much more detail how this node graph works. But now moving on to some of the actual tangible features that we built. So I'm just going to run through some of these real quick. So we now can import bitmap images as layers. And let me show off a demo for each of these. So on the train to GTC, which I also went to, we'll talk about that later, but I made this artwork here. And basically, we're starting out with an image of Yosemite. And this is imported here. We can always scale it around and things like that. But we can then put this folder here with the artwork. And then I also gave it a frame and I gave it a label. And that makes it much easier to trace artwork and do other things that involve a mix between raster and vector art. This is not the full capabilities of the entire raster-based editing yet, but this is a sort of a nice way of making the editor more useful right now while you're just doing SVG editing at the moment. So then we fixed the panic handler, which was panicking. So we previously had a panic handler that is used to detect when there's a crash in the Rust backend. And when that Rust backend crashes, we display an editor warning for the user. So if we want to say, let's create a crash, it will normally pop up with this dialog. But the panic handler was sometimes panicking itself, which meant that the dialog did not crash and it just froze up and the user was confused why. And then we also have more code documentation as well as various smaller bug fixes. And then we have a new feature which allows you to create dashed lines and make it so the lines, or the outlines, like the stroke, has joins and caps. So I'll show you how this works now. I will reload this since we intentionally crashed it. But let's make a interesting pointy line. And now let's say that I want the ends to be rounded. So I'll scroll down here and say I want round, and that gives it a rounded edge here. Or we can go and say a square edge, and this actually extends past the edge. So if we go back to the default, that's how it normally looks, but then we can extend past it, similar to rounded, but more squared off. And then also we can do the line joins. And what this does is it allows us, right now, it just has this sharp edge here, but we can also say bevel. And that gives all these edges a beveled corner. And then also we can give it a rounded corner here, like that. And then finally, if we want to go back to the default of miter, this is the normal way it works, but we can change that limit here. So anything, basically this forces a bevel on things regardless of how sharp they are. But then we can increase it, and now only the, you'll see that this one is beveled, but the other ones are not beveled because they are a less tight corner. And if we drag this around, we'll see it snaps between that. And if we change this now to 1, now it's now it works with a less tight corner. And if we change it to 3, now it permits even sharper corners, but now it got sharp enough there to switch. So that's very helpful. And also we have a dashed offset here. So we can go and say, let's say we want a dash of, oops, no, that's the dash offset. Let's say we want every pixel there to be a dashed line. Or we want to say every pixel, there's a dashed line, and then there's a 10 pixel gap. Or we can say we want that, and then we want a different set of them to be every 100. And then we can say, you know, then 20. And basically it allows you to have a 1 pixel separated by 10, separated by 100, separated by 20, and repeating there, and create some interesting dashed lines like that. So you can also, of course, now change the color, change the thickness. We had this before, but all of that now works, and it's very easy to make much more interesting and complex styles of shapes. And OK, we also have new website content. So we have these, the new app screenshots that I just showed off with the node graph and the layer panel, and additional information on additional pages of the website. So feel free to check that out at graphite.rs. It is pretty much ready to show off to people now. So it's taken some time to build the content for the website, but it's all ready now. So meanwhile, we were also working on a big ongoing refactor of the internal way that we represent our vector shape data. We've currently been using the Great Kerbo library, but unfortunately, it doesn't really represent the data in the format that we need because it's much more analogous to SVG. However, we need something that's more like a list of points and edges. So we've been working on refactoring that. It's a really big job, but hopefully that will be done soon, and that will allow us to make the pen tool more powerful, for example, by being able to add points in between existing points. So you can just basically take an edge and add points along the edge, as well as deleting existing points. And that will make the editor much more powerful. We also have been building the node graph. So I showed off the design workshop, the results of that and the mock-ups, but we also now have some work going on towards building the front end. So we can see here, this is not very interactive yet, but we do at least have some of these nodes showing up interactively in the editor. And this is, we can also go ahead and like drag outputs. Actually, I guess this technically counts as an input, but we can just drop them right now. I can just make a bunch of spaghetti noodles everywhere. And soon enough, this will allow us to drag them into the sockets. Currently, I just drop them in random spaces, but this allows us to continue building out the additional features that are going to be used for the rest of this stuff. So yeah, stay tuned for that. Hopefully we'll have more progress in the next month. And then additionally, we have some backend progress. So we'll show off how that works in a minute. And then finally, we visited GDC to spread the word about Graphite. It was very fun to meet many people and talk about the vision and spread the word, basically. Yeah, it was very fun. And make some connections that will hopefully be useful to the lifetime of the project. So here we are. Now let's move on to True Doctor going over how we are building the backend for the node graph.
All right. I have to admit my slides don't look as fancy as Steven's. I'm very sorry for that. But I'm going to go about it. Well, I started implementing the node system, and I'm going to go through like some interesting design details that came up. So what we have each node is essentially just a Rust function. And if you've ever dealt with programming in Rust, you know that there are sometimes issues with borrowing and lifetimes. And if you've ever gotten the error, can't return like temporary value owned by a function, and you can't return that value, that's because like if you call a function and the function you call creates some owned value and then returns a reference to that owned value, the value will go out of scope. And that's a kind of an issue when you want to build a full system, because in Rust there are ways to work around that. You can always, you can just return the owned variant of that value. For example, instead of returning a slice, you could just return the vector. But this creates an issue in our node graph system, because we want to allow the output of each node to be fed into any number of input nodes. So one approach to solve this is to add so-called caching nodes. These are, if you come from a functional programming background, these are monads, caching monads, essentially, and they are essentially a way to retain state inside of the function call graph. And this cache node then owns the data that it received and can hand out references to that data. But we want to, one part will be that we can actually compile in real time the node graph and re-inject that into our function, into our program. But for now, we will just dynamically compose the Rust functions. And then we run into some issues, because if you've ever worked with Rust trait objects, and especially the any trait object, it has a pretty strict requirement to only work on types with a static lifetime. And we can see on the next slide, probably, yeah. This is a very brief simplification, and we're going to do a little bit of category theory today. So this is the category type. A category is just a thing that contains objects. And in this case, we have types as objects. So we have a few integers, a string slice, a copy on write, string slice, or copy on write of anything. And we also have the any trait. And in regular Rust, you can only those arrows that are shown here are conversions. You can cast a U8 into a U16. You can downcast a U8 into you can turn a U8 into a dyn any. So that's an any type. It's essentially used to store a vector of objects. If you wanted to store a vector of both 8-bit and 16-bit integers, you could store them as any objects inside of that vector and then turn them into the correct type at runtime. And Rust provides a trait that does that, the any trait, and it uses the downcast ref method to turn it into a concrete type. But this we run into some issues, because this only works for static types. Rust doesn't encode lifetime information, because lifetime information is actually just used during compile time, and it's in no way represented in the final binary. Like, it's just thrown away. It's just for checking. So we can't do runtime lifetime checking. And there are a few ways that we can solve this. Go to the next slide. We have the type category that we've seen before. And on the top right, we now have a static category. The static category is essentially just the same thing as the type category, but everything has a static lifetime. So the only difference is that now we have the static string slice and static copy on write. So those are just, well, we have static references for each type. And now we can actually use the any trait to convert between the static string slice and the copy on write. I'm going to show that with a few arrows next slide. And you might have, you might have been wondering what those double fat arrows are. Those are what's called a functor. A functor maps every object to a different object. In this case, we have the same object. Its U8 is mapped to U8, and the arrows are mapped to the arrows. So yeah, the arrows are called morphisms, and the functor, the double arrow, maps both objects and morphisms to objects and morphisms of the static category. Now we have a second category, or rather third category, the bottom right, the lifetime category. And in this category, I've annotated the lifetimes for each of our types. So the U8 and U16 have a static lifetime because they don't contain references to, like, they don't contain non-static references. This is how, like, the lifetime of a type is defined in Rust. And I've now changed our any trait to actually accept a lifetime. And what we're trying to do here is that we treat lifetime checking and type checking as orthogonal concepts, and we separate them. So instead of doing both things in one step, like encoding the lifetime information in our binary, we instead add a lifetime to our trait, and then we use any to do the type checking, which is the top right, and we let the Rust compiler infer the correct lifetimes, the bottom right. And in blue, I added the arrows that this allows us to actually draw, because the lifetimes, it's valid to cast a named lifetime to the anonymous lifetime, and it's also allowed to coerce the static lifetime to a named lifetime. And if we then combine, like, what we essentially can do is that we take the arrows from both the lifetime category and the static category, take the not the union, the intersection, like those arrows that are in all categories, that we can then add them back to the type category, and that is which types we are allowed to convert into. That's just a thing that came up, and it's not very well supported by Rust, but there are fortunately crates that deal with exactly that. Just wanted to give small, small X-course. And on the, but this leads to a different issue, right? We still have to store the nodes somehow. We can now store the nodes in a vector of nodes, which is a vector of, like, dynamic node objects. But for example, the add node still has a reference to its inputs. And if you've ever tried to create self-referential structs in Rust, you know that that's usually not a good idea to have, like, one field of a struct try to have a reference to another field of a struct. But we can actually implement our own little data structure that provides a safe abstraction. We just treat it as a pure stack. So if the stack is empty, we don't have any elements in it. And then we push on the first value node, we push on the second value node, and afterwards we push on the add node. And the add node can only reference data that came before it. So the add node can only reference data that was pushed onto the vector before the add node was added. And if we want to remove the value nodes, we first have to pop the add node before we can remove the value nodes. So this kind of stack abstraction allows us to have safe self-referential structs, and the lifetimes actually work out. So that's just another thing that we are going to implement in the next few days. Yeah, I think that's it for like the technical bits. Back to Keaton.
Okay. Yes. Thank you, Dennis, for that. It was very interesting to hear how we're doing some of these things. If any of the audience here are interested in joining in that fun challenge, please join our team. We are building this all as a hobby, and the more of us that can join, the faster we can get working on getting this to exist. So feel free to try it out right now in your browser. Editor.graphite.rs is the website, and that will instantly open up the editor, and you can just start making some artwork. And then also you can visit us on the website. Please check it out now that we have one finally. It's exciting. So please check out graphite.rs for the website. And then join us on Discord. You can go to discord.graphite.rs, and that will open up the Discord invite link. And even if you just want to hang out in the channel or occasionally basically just be there for when we very occasionally do an add everyone to notify of important updates or anything, please just join that and feel free to participate or not participate or lurk or whatever you want. And then also come to GitHub and give the project a star. We'd appreciate that since it helps build momentum. And we also have some beginner-friendly issues that are open. And you can also check out our sprint board, which lists basically all the features that we have planned for each sprint. And you might find one that's interesting. So yes, we'll see you next month. Thank you.
Awesome. So I gotta say, like, I've recently gotten into like some of the type theory stuff that Rust has, but from a very, very high level. And so I think I quite enjoyed that overview of some of the things. And like, just like a little anecdote for myself, like it was literally a few days ago where I understood why the dyn keyword in Rust is useful, because I've always done like coding questions in Rust, and for that you just use vectors and iterators and stuff, and you don't care about types at all. But this is like super cool to sort of see under the hood, and I'd love to see maybe like a blog post in the future about how Graphite does some of this stuff, because there's, I mean, with the stuff that you're thinking about, it can be really elegantly represented in Rust, but you really have to sort of think about it a lot. So yeah, that'd be really cool to see.
Yeah, and we do have a blog now, so we can hopefully start writing ourselves some posts.
Awesome. Good
stuff.
To
subscribe to the RSS feed for that, by the way.
Yes, and if you send me the link, I'll put it in the presentation slides.
Sure. It's also just easily visible on the website.
Oh yeah, graphite.rs probably. Yeah, awesome. Cool. Yeah, so I think that is it for Graphite for this month. So I'm definitely excited to see where we go over the next month. And also, like, this graph editor is like mind-blowingly cool. And so, I mean, I do a lot more video editing than I do photo editing. And so I'm kind of thinking of stuff like this in terms of like, oh, I wonder what other applications are for this sort of base of like graph editing on these things. But I'm kind of curious, when you're in like design meetings and stuff like that, how do you come up with like knowing that either like the node graph or just like the representation of the scene is designed in like a usable way that uses language of like graphics editing and stuff like that?
Yeah, I mean, it's been several years that we've been toying with thousands of different approaches, well, many hundreds of different approaches for representing the visual concepts in a way that's both intuitive and not overly complex. It's very easy to come up with a solution that just gets too complex and uses existing metaphors and existing concepts that people are already familiar with conventional tools. So basically, I think we finally mostly figured out the stuff that we've been trying to figure out this whole time. One of the hard things is that there's this fundamental difference in the concept with how data flows through a node graph in a traditional node editor compared to how data normally is composited in the compositing stack. And they're basically, you have to be able to treat those separately, but you need to also be able to represent them in a way that is not overly confusing to the user. And another interesting thing is that typically node graphs either go from left to right or top to bottom, but they never go from bottom to top. But stacks, a compositing stack actually always goes from bottom to top. And we don't want to reverse that because that's going to confuse users massively. So we could have done it where the layer panel is reversed from the node graph in order to preserve conventions for both of those worlds. But that would have been confusing. And we kept thinking of all these ways around the problem. And what we ultimately found is that we can actually make it so that the flow of data, just sort of like something plugs into something, that can go from left to right, which is conventional for a lot of languages, or a lot of node-based languages like Blender shader editor or compositor, or a lot of other tools like that. Those typically go from left to right, but then there are others that do go from top to bottom. But what we're doing basically is we are making it so that compositing goes vertically from bottom to top. And even though it's a little weird that it goes from bottom to top, it makes sense because it is compositing, and people are used to their stacks that composite, where you put a piece of paper underneath and then you put a piece of paper on top, and you see the paper that's put on top because that's the one that's above the one below.
Yeah.
And then all of the other things that involve the flow of data, that is left to right, which is also conventional. And by splitting it up into these axes, that finally was a solution that actually helps avoid the confusion. And then we also had to figure out a way to marry that concept with folders, because folders themselves are actually subgraphs, but we want them to all show up at the same time because you don't want to have to like dig into each individual folder to see more of the broader picture. So all of those concepts together have basically just taken several years of iterations. And I think, I'm sure there will be some small tweaks here and there to make it work for edge cases we haven't thought of, but I think we finally figured it out. And that's been something blocking us for a very long time.
Also, on another note, like Keevan and I, when we sit in design meetings, we also sometimes like but we have to like marry a clean backend and a good user front-end experience. So I'm always high on my like mathematical description of, like, for example, the compositing is actually, those are monads, and we have a compositing monad. But if you call it a compositing monad, no one's gonna understand what you're talking about. So we kind of always have to find a middle ground where we kind of can keep the clean modeling of the backend, and then find an interface that like works with the front-end design, and sometimes the backend can inform the front-end to make a sensible, consistent, logical front-end, and vice versa. So the front-end can also inform the backend, and the modeling can go in both directions.
Yeah, I see. Yeah. And so, I mean, it definitely, like, this is definitely like something that I look at and I'm like, wow, how did you like go and plan all of that? So it's cool to hear sort of the mathematical approach compared to either like how it's going to actually be used, or thinking of like the end users and like the design language of thinking and stuff like that. So awesome. Good stuff. Well, I think we'll end it off here, but thank you so much, Keevan and Dennis, for showing stuff off, and hopefully we'll see you next month.
Yes, thank you.
Yeah, thanks.
All right, so we're at the end of the meetup. One thing I did want to mention before the end is that for my Ludum Dare jam entry that I was mentioning, I'm actually doing all of my assets in Graphite. And so here's an asteroid that I made. Pretty cool. And it took like 20 seconds. And so I was like thinking in terms of like, I'm not an artist, I'll just toss some circles on the screen. So there's an asteroid. Here's the Earth. I've tried to model Europe and Asia, and I didn't look at a map, and I'm missing like all of the Middle East now that I look at it again. But I tried. And so and then also I did some stars with just hexagons. And so I'm making use of what I know, keeping it nice and simple and stuff. And so now at the end of the meetup, a few things I have to announce. And so first of all, the newsletter is in progress right now. And so if you haven't written a section about the cool stuff you've been working on this month, I believe, actually I should check because I'm not the editor of this month. it doesn't look like we have. Okay, it looks like we still have stuff open. So if you have time in the next few hours, go off and write a section about something that you've been working on. Also, I kind of just put this together during the meetup, but I really want to run like another Rust graphics meetup. Like we're streaming with StreamYard, and I pay like for like $50 a month or something like that, and I just want to stream more stuff because it's pretty easy to do, and the first Rust graphics meetup was really awesome, and so I'm going to put out posts, or I guess a forum on Reddit and Twitter and Discord, for anybody who wants to come and give a talk about stuff that they're doing in the Rust graphics ecosystem. And this is more stuff that's like under the hood, and so either stuff with engines or rendering stuff, or just like, I don't know, if you have a cool topic that's like in this field, definitely fill out the forum. I really want to see a lot of different talks if I can. And then other than that, yeah, we're at the end of the meetup. So we'll hop over to the Discord, and I'll be hanging out there in the voice channel for a little while. So come talk with the presenters, talk about what you've been working on, and we will see you over there. So thanks for coming out to this month's Rust Gamedev Meetup, and we will see you next time.